Hey there, algebra friends. Shinner's back here, ready to walk you through 9.1.1. Hopefully, you had a great spring break, and on Monday, we had you investigate and just start thinking about the quadratic formula. So, we are going to practice that along with practicing what we already know about quadratics to start off chapter 9. Before we jump into the math, I would love to know what have you been doing? What have you accomplished? Maybe over spring break, or I tried to set kind of a non-work goal for myself over spring break. Something I always kind of wanted to be better at, but I never knew quite how to do, is braiding my hair. So I practiced some braiding skills. Maybe you can see it up there. So that's what I worked on non-school wise over spring break. I was working on my braiding skills. And I would encourage you to think about maybe something you've always wanted to be better at, but never had the time. Maybe it's a video game, maybe it's braiding your hair, maybe whatever it is. Tell us at the top of your paper, maybe something you've already accomplished during your kind of time at home, or something you hope to accomplish. My mom's is to learn the electric slide. I'm not joking. Mine was to work on braiding. So let me know what yours is. I think it's a good thing to keep keep ourselves busy, right, during these times. All right. So with that, let's jump in here, guys. 9-1 wants us to use the zero product property to solve the quadratics. Okay. So in letter A here, folks, before we start identifying our A, B, and our C, we need to make sure, what does my quadratic have to be set equal to? Remember, in order for us to solve for an x-intercept, it has to be set equal to 0. My y has to equal 0, and in this case, it equals 9. So I need to fix that. I need to subtract 9 from both sides of my equation, because in order to solve for the intercepts, it has to be set equal to 0. Hence the zero product property, right? It's got to be set equal to 0. So -6 minus 9, what does that give me? Use your calculator or Desmos or that new link we set out. I believe that should be -15, right? Equals 0. Alrighty, now we can factor and use the zero product property. 3 times -15 would give me -45. 4 at the bottom, and then A is 3. Okay, so what multiplies to -45 but adds to 4? Alrighty. Okay, let's think about this. So what would multiply to -45 but add to 4? So think about our factors. So I'm going to play around on my calculator. I actually didn't do this ahead of time. I didn't think about this ahead of time. I think 5 and 9 are going to be our magic numbers here, folks. So 5 and 9, because they have a difference of 4. Since I wanted to add to a +4, I'm going to make my smaller number negative. Okay, so let's divide and slide here. -5/3. I cannot simplify that any further. So I'm going to write it like that and then slide that 3 to get 3x minus 5. 9 divided by 3, that I can simplify to be just 3. All right, so all factored out, it's going to be 3x minus 5 times x plus 3 equals 0. All right, here's where the zero product property comes into play. I'm going to set both of these guys equal to 0. Now remember what I said, we should just end up getting the opposite of what was in our diamond to begin with. And what do I get? I get 5/3. That's the opposite of -5/3. All right, now over here, x plus 3 equals 0. I'm just going to get x equals -3. which is the opposite of plus 3. So that's the long way around it, but the shortcut is you should always get the opposite, okay, folks? In letter B, they've done the hard part for us, guys. I've got it in factored form. I've got it set equal to 0. So now I'm just going to set each of these factors equal to 0. So I either need 3 to equal 0, I need x minus 5 to equal 0, or I need 2x plus 3 to equal 0. So let's solve each of these. Can 3 ever be 0? Heck no. What about this middle guy? X equals 5, that would be the opposite of a negative 5. So that relationship that I look for is still there. Oops, I divided by 3 over there. I meant to divide both sides by 2. Alrighty, so I get x equals negative 3 over 2. Alrighty, so those are my 2 answers there for that one. When it's already factored for you, it's a little bit easier, right? One thing I want to note, you can always check your answers, and we really encourage you to do that just by typing these into Desmos and clicking on the x-intercepts and making sure your answer is the answer on Desmos, okay? Let's work on these next 2. Letter C, shout out to Gibbon. What should we always look for first? The greatest common, rhymes with tractor, factor, our GCF. So this is just a little binomial, meaning it only has 2 terms. So for those ones, it's always good to check for that greatest common factor. So between x squared and 6x, they both have an x. So what I'm doing is I'm really taking out an x from each of these terms. I'm dividing out an x, and I get this. Now that it's product and factored and set equal to 0, I'm just going to set both of my factors equal to 0. So I either get x equals 0 or x plus 6 equals 0. So I get x equals negative 6, or I get x equals 0. Common tractor, common factor, right? So those are my 2 x-intercepts, folks. All right, so letter D, this is going to be the first one that is really asking us to use the quadratic formula. So you were introduced to this on Monday. Let's first just remind ourselves, what is the quadratic formula? Do you have to have this memorized? No, but I do because I'm a math teacher. Alrighty, so we need to first, I like to still get in the habit of looking for a greatest common factor, but in this one, between 1, 4, and 1, no, there's nothing I can factor out. Make sure it's set equal to 0, which it is. And now let's get, to using the quadratic formula. So I could try to factor this one, but it's asking us to use the quadratic formula, so that kind of leads me to believe it might have some irrational roots, and that's why we might have to use the quadratic formula. So first thing I'm going to do is I'm going to identify my A, my leading coefficient, my B, my middle term, and my C, my last constant term. So it looks like my leading coefficient is 1, my middle term is negative 4, and my last term is a positive 1. Check that you're including the negatives and you're getting that all right, okay? So now I'm using my formula. What is the opposite of a negative 4? A negative 4 is going to end up being a positive 4, but we'll write it like that for now. B squared, negative 4 squared, minus 4 times A times C, all over 2A, all over 2 times 1. Alrighty, let's clean this up a bit. Opposite of an opposite 4, like we said, is a positive 4 over here. Let me change colors. So opposite of a negative 4 would be a positive 4, plus or minus. Okay, now underneath the root is what I call a discriminant. Okay, so this is called a discriminant. I would calculate this first. So either in your calculator or Desmos, let's type this guy in. Negative 4 times negative 4 gives me 16. Minus 4 times 1 times 1. okay? What does that give me? 12. So that means my discriminant is 12. That's what's going underneath the root. All over 2 times a would just be 2. Alrighty, so here's where I've got to break it into 2 separate options because of that plus or minus. So in one answer, it's going to be 4 plus root 12 over 2. My second answer is going to be 4 minus root 12 over 2. So these are going to be irrational x-intercepts. That means they are icky decimals that go on and on and on and aren't nice decimals like we're used to working with, okay? So if you wanted to type these into your calculator or Desmos, you can do that. Otherwise, I kind of like them like these because they're exact answers. But just I know some of you folks like to see it as a decimal as well. So 4 plus let's search for our square root. 4 plus the square root of 12. Oops, I didn't get that underneath the root there. Now that's the numerator, and now we're going to take that and make sure it's in parentheses because I want to take that whole thing and I want to divide it by 2. Okay, oops, I don't want that outside. I want that outside. Okay, divided by 2 gives me 3.73, okay? So my first x is positive 3.73, and now I'm gonna get my second x. Sometimes people might write it like this, x1, x2. I saw some of you guys writing it like that. I'm not sure if you've seen it in, who knows, good idea is just to Google quadratic formula if you want more examples, but you might see it that way. You don't have to write it like that, but just so you know. So now we're just gonna change this to be 4 minus, and it looks like I get about 0.27 if I round correctly. So my second x-intercept is 0.27, all right? So that those are my x-intercepts for this guy. Again, if we wanna check this, I'm just going to type this into my Desmos or your graphing calculator, whatever you're using. So we have x squared. No, I want it up there. There we go. X squared minus 4x plus 1, right? I think that was it. All right, so let's click on it, make sure we got the right answers. Yay, we did. All right, so this is a great tool to check your answers. Please utilize Desmos. Okay, so there's the quadratic formula. So why do we use the quadratic formula? Because there's no way we could have used our factors, our diamond method, to get those icky irrational numbers, okay? So that's why we're utilizing the quadratic formula. You can use the quadratic formula always. It will work every time, but it's only completely necessary when we have those irrational numbers, okay? So now, guys, it is really important that you try each of these homework problems, okay? So with the time we have left, I can get you started on the homework here. For each of the following equations, indicate whether it's a line or a parabola. So remember, parabolas are when it's a quadratic. So when my biggest exponent is 2, okay? So let's take a look-see here. When do I have a biggest exponent of 2? Here and here. And then when I have no exponents, when I just have x's and y's, that's a good indication that it's going to be a line. So you could type these all into your calculator or Desmos too and look at the shape, and that will also tell you what shape the graph is. Okay, guys? So always remember you have Desmos. All right, for 9/8, this is a multiple choice, okay? So your answer is just going to be one of these circled. So what you guys need to do is which equations below are equivalent to this, okay? So let's just clean it up a little bit and see which of these are equivalent, okay? So I'm going to distribute this 1/2 through. So 1/2 of 6 would be 3, 1/2 of 14 would be 7, plus 5x equals On this side, 2 and 8 are like terms. So that would give me negative 3x plus